Hey everyone, hope you're all doing very well and welcome back to another video here on the channel. In today's video, we're going to be looking at the performance of a battery pack, specifically this HRB 4000 milliamp hour 6 cell that is rated at a 60C discharge rate. We're going to be taking a look at this, and we've done a video in the past, and this is going to follow that format, except bring it to a completely different level. So we're going to ultimately find out, is this battery pack good or does it suck? I've spent a bunch of time soldering up a bunch of test leads, assembling a bench that can work for us to capture a bunch of metrics. I've even written code to take a bunch of data and then spit back out metrics that we're going to be interested in for the entire discharge of a battery pack. I'll continue to beef up the setup and show you at some point what this looks like and how it is all done. Now, what's interesting about the process that we're going to use is that if we determine or come up with a different performance metric sometime in the future, we can go back into all of the tests that we've done, update the data, and then show the performance metrics for those tests that have been done in the past. That is going to allow everything that we test, all battery packs that we test, to be on the same playing field. Now, I haven't quite figured out exactly how all of this is going to work. And what I mean by that is that 3 of 4 companies that have reached out said to me, here's a battery pack, throw it into your radio controlled vehicle and do a video on how it's performing for you in that vehicle. However, what I wanted to do is throw that pack onto some sort of testing platform and get the actual data in terms of performance of this battery and compare it to the actual battery specification that is found right here on the label. For example, this one here is a 60C. I want to compare against the actual data here and let you know how batteries actually perform. This is what you're interested in, not just for me to throw it in my vehicle and say, yep, this one's good. That's not what we do on this channel. We work from real data, from real knowledge, from real engineering type concepts. This quickly showed me that I'm going to have to fund the battery pack projects in order to bring more battery packs here to the lab so that I can test them. And then I'm going to end up with a whole bunch of battery packs that I got to figure out what to do with them. If you have any idea how to solve this problem or what I should do in order to continue to test, I'm pretty much fully committed at this point. Let me know in the comment section below. I do believe that the truth of these battery packs is a must-needed thing in our hobby, and I want to bring that to everyone so that we can really understand what is going on with these battery packs that we buy. Let's now take a look at some data coming from these battery packs. Very first thing to take a look at is the internal resistance measurements done by our charger. These come right on the screen 1 minute after we start the charge process, and I measured both battery packs. This actually is the better of the 2 batteries that I'm showing you here. The other one, it's not that much different. I think between this one and the other one, it does average out to 4.1 milliohms. So now that we have this, we want to jump over to another screen here. This is the screen that you see when you click the link when you are a Patreon member of the RCexplained community. You click the link in the most recent post and you are going to make a copy of the RCexplained calc sheet. So we can go ahead and do that, make a copy of this specific spreadsheet. Once we do that, we arrive at this screen, and from here, we can actually take a look at what is new just this month. When the video comes out, this will be available to all the Patreon members, and that is the new brushless motor specs tab, where we can determine the kV value of our brushless motor using the drill method. We enter in the voltages on the phases, and we enter in the RPM at the motor at the drill. So this is going to be the value that are there, and then it calculates the kV of the motor right here. For today, what we want to do is we want to take a look at another function here, and that is the real LiPo RC calculator here. We want to determine what the internal resistance is of our cell as we've done through the charging process, and then we want to enter it into this spreadsheet. So the capacity of our pack is going to be 4,000 milliohm, and we saw an average internal resistance of the cells there in 2 packs of 4.1 milliohm. So this now calculates that the battery pack's calculated C rating is actually 19.5 C versus the 60 C that is found on the battery. In addition to that, At a C rating of 19.5, the maximum continuous current should be around 78 amps for this particular pack. Another thing I do want to note here, we'll talk a little bit more about it at the end of the video, is this maximum continuous current. I do want to test this. Now let's go ahead, take a look at the data that we've been able to capture. This is the load test that we did do. It is a 105 amp load test. We got a bunch of data here. The total milliamp hour that we extracted on average from the 2 battery packs, both of them are 6S packs, is 3,394 milliamp hour. At that point, I did actually have to stop the test because at 100 amp continuous draw, it definitely exceeded the 60°C mark, and actually it came up pretty quick and passed it pretty quickly. The milliamp hour capacity that you have available until the battery pack hits 3.50 volts is about 814.8 milliamp hour. That's not all that much considering it's a 4,000 milliamp hour pack at only about 100 amp to 105 amp load test. The time that we take to get there is about 30 seconds, and then you're at 3.50 loaded. The voltage around the 10-second mark was 3.56. That is, again, it's quite low. The energy per cell ended up coming out to 713.2 watt minutes. If you wanted the entire pack, you just multiply this value by 6. And the average cell wattage that we saw throughout this entire run was 350 watts per cell. 350 times 6 is the overall average wattage that we saw for the duration of this discharge. Now you can see the cell voltage, how it drops immediately, and it sustains about the same right up to the end of the pack. The current value, you can see that it's kind of fluctuating a little bit, and you can see how it actually goes up and then it comes back down. So somewhere in here, it's receiving about a temperature that it's happy with, and it can actually perform a little bit better, but not as good as it could perform at the very beginning of the pack. So this is really interesting to see, and then it kind of tapers off, not by much, and settles in until it fully depletes near the end. And at this point, it was greater than 60°C, and I stopped the test. Ultimately, this does tell us that it failed this test, which is really only a 25C test, considering it's about 100 amps, and we're testing this on a 4 amp hour battery pack. There you have it, guys. Unfortunately, this specific battery pack did not measure up to delivering more than about 35% of its rated C rating. Therefore, guys, unfortunately, this battery sucks. However, even with that said, if you're looking for inexpensive battery packs and you don't plan to take a lot of power from them, and you're not interested in the maximum amount of power that you can get from these battery packs, these probably could still work for you, but you have all the data and information to know and understand, and the level of expectations that you have for these battery packs. At some point in the near future, I do plan to take the data that I've collected and probably more than likely throw it onto the Patreon website. Another video that I do plan on doing is taking this exact same battery pack and measuring up against the C rating that we have been able to calculate right from that Patreon calc sheet that I showed. Now this here did come out to somewhere around the 75 amp mark that we should be able to test, and it's going to handle it. I'm going to throw this on a load test at 75 amps and see if it can actually pass that test. Make sure that you're subscribed so you don't miss not only that video, but all of the future battery tests that we plan to do here on the channel. As always, like the video if you did, and guys, I will see you in the next one. Enjoy your day, enjoy your week, have a good one.